Initially, excess ammonium hydrogen sulfide is placed in a 5 decimeter cube container at 218 degrees Celsius. The container is sealed and the reaction is allowed to reach equilibrium. And you can see that here's your ammonium hydrogen sulfide forms ammonia plus hydrogen sulfide. Yeah, you've got delta H is greater than naught, which means it's endothermic, which means the forward reaction likes heat. State the Chatelier's principle. Okay, now you guys need to go through your exam guidelines and go and find the Chatelier's principle and go learn it properly. But basically what it says is that if we mess with the one side, it's going to do something to fix it. Okay, in other words, it's going to change this reaction in order to undo anything that we do to it. Okay. What effect will each of the following changes have on the amount of ammonia? So we want the amount of ammonia, okay, at equilibrium, right? Only increases, decreases, remains the same. Okay, it says more NH4HS solid is added. Okay, so what are the things that are going to affect the amount, how much we're going to get out? It's going to be the concentration. Okay, what else? The temperature because of the endothermic exothermic thing. What else affects the pressure? Not really, even though those are gases. Concentration, temperature, catalyst, no, that's the rate of the reaction. Pressure, no, because that's a solid. Okay, I think we're done. So is this going to the amount of NH4HS going to make a difference? No, because this is a solid, and it doesn't matter how much solid you place in front of this reaction, it's not going to give you any more ammonia. So that is going to be remains the same. If the temperature is increased, which reaction is favored? If the temperature is increased, the forward reaction is favored because this is an endothermic reaction. And if that's the case, we're going to end up with more ammonia. So this is going to be increases. And why? Because the forward reaction is endothermic, which means it likes temperature. Now it says the equilibrium constant for this reaction at 218 degrees Celsius is 1.2 times 10 to the negative 4. So Kc is 1,2 times by 10 to the negative 4. So therefore the Kc is 0,00012. Okay, 1, 2, 3, 4, yeah. Okay, so it is, that's how, so therefore it is smaller than 1. And then we've said, okay, and we know that Kc is equal to the concentration of NH3H2S, and it's not over ammonia, okay, ammonium hydrogen sulfide, because that's a solid, so it's just over 1. So that's what your Kc is. And it says calculate the minimum mass of NH4HS that must be sealed in the container to obtain equilibrium. So we need to find the number of moles of these in order to get the number of moles of this in order to get the mass. Okay, so we know that Kc is 0,0012 equals the concentration of NH3 and the concentration of hydrogen sulfide. Okay, so do you agree it doesn't really matter whether we're looking at ammonia or hydrogen sulfide? We're going to get the same thing because they are identical. Okay, the concentration of this times by the concentration, that gives you 0,012. So it's a 1-to-1 ratio. Okay, so therefore we can just look at one of these two. So do you agree that we could pretend that we had look at just at ammonia, and we could say, okay, fine, that the concentration of them squared is equal to 0,012. Therefore, the concentration of this is going to be the square root of 0,012. Okay, so therefore we can get out our calculator and we can say 0,012 and square root it. Let's try again. We can square root 0,012, and that is going to be, so the concentration of the gases, each of them is 0.11. 0.11. That's the concentration. We know that concentration is equal to number of moles over volume, and the volume is 5 decimeters cubed. So therefore we can get the number of moles that we're getting of each of ammonia and hydrogen sulfide, because it's a 1-to-1 ratio, by substituting into this. So it's going to be 0.11 is equal to N over 5. Therefore the number of moles of this is going to be 0.55. So the number of moles of ammonia is 0.55, the number of moles of hydrogen sulfide is 0.55, and because this is also a ratio of 1-to-1, the number of moles of ammonium hydrogen sulfide is also 0.55. So the number of moles of NH4HS is 0.55. Now to get the mass, what do we need? We need the molar mass. So you guys need to get out your periodic tables so you can find the molar mass of this, okay? So the molar mass of NH4HS is nitrogen, which is 14, plus 5 times 1, which is 5, plus sulfur, which is 32. So that is going to be 19 plus 32, which is 2 and 1 is 11, carry 1, that becomes 51 grams per mole. So therefore we can use number of moles is mass over molar mass. We've got the number of moles as 0.55, and we've got the molar mass, so we can find the mass. So we've got 0.55 times by the molar mass of 51 is going to give me the mass, and I'm going to get up my, so it becomes 0.55 times 51 equals 28.05. 28.05. So the minimum mass of ammonium hydrogen sulfide that must be sealed in this container is 28.05 grams. Okay, and that's your final answer. Have a great day.